Okay, so hello everyone and welcome. Today we have a very special guest, Melanie Wise, the CEO of Fetch Robotics. Melanie grew up in Chicago and ended up attending the University of Illinois in Urbana-Champaign. And eventually she became an employee at the robotics incubator Willow Garage in Menlo Park, which is essentially a robotics research lab. And afterwards, she ended up starting Fetch Robotics herself, which is where she is today. And now that was a very brief introduction, but I'd now like to pass it on to Melanie herself to share her journey into robotics and how she got to where she is today.
Thanks. So, before I start, I just want to say that anyone can ask me questions at any point. I typically don't speak for very long. I kind of want to answer as many questions as you might have, either about entrepreneurship, college, things like that. I'm more than happy to answer all of those questions. So, I started my journey into robotics in college. So I went to University of Illinois. It's a very large school. There's a lot of things going on at that university, and um, however, I grew up very poor, and so I didn't have a lot of money to go to university. I actually got a Pell Grant, and I worked multiple jobs while I was there. But as part of my strategy to get the most out of it, I decided to do 2 degrees at the same time so that I could get the most out of my dollar. And so I studied mechanical engineering and physics engineering. And one of the things that I didn't do in college is learn how to program. And so I would say learn how to program at any of the more standard languages. I learned a little C. I learned a lot of how to program on microcontrollers, things like that. But I never really developed a lot of the professional engineering skills needed for becoming a programmer. And so during my undergrad, I finished my undergrad, and then I went on to my master's degree in mechanical engineering, and then I started my PhD. And during my PhD, around that time, so that was around 2006, 2007, the DARPA Urban Challenge was getting started. That's an autonomous car challenge that started in 2004. There were 3 different phases of the autonomous car challenge: the first urban challenge, or the first grand challenge, the second grand challenge, and then the urban challenge. And a group of alumni started a project for doing autonomous cars at the university, and they were being funded by someone out here in California. Actually, one of the guys that developed Backrub. Backrub was the first Google search engine, and he decided that he wanted to start a robotics company. And so I was out here programming the autonomous car. So we basically reverse engineered it. My specialty is in dynamics and controls. And so I wrote a lot of the control system for it in the low level microcontrollers and things like that. And then this guy came and he wanted to see a demo of the car. And after he saw a demo of the car, he came up to me and he said, "Hey, look, I'm starting a robotics company. It's called Willow Garage. You should come join it. Drop out of your PhD, forget all of that schooling, uh, and come to California and work on robots." And one thing that you guys may need to know is at the time there weren't that many opportunities in robotics in terms of employment. There was iRobot, there was Boston Dynamics, but outside of that, there weren't many places where you could go become a full-time roboticist, maybe SRI. And so, for me, it was like, oh, that's kind of cool. But I said to him, like, look, I can't afford to leave school. I'm the first person in my family to go to college. I have all this debt, and, I should finish my PhD. And he said to me, look, if you're here next week, I'll get rid of all your college debt, and that won't be a problem, right? And I was like, I guess not. And so I dropped out of my PhD program and I came to California, and I became debt free because someone offered me a very compelling startup deal. And so I ended up working at Willow Garage. Willow Garage became one of the most famous institutions for robotics. Um, and and we worked on a lot of open source software. But one of the things that was really difficult for me in my first year at Willow Garage is I'm a classically trained mechanical engineer and physicist. I have almost no background in programming, and I learned almost exclusively everything in MATLAB and other kind of scripting languages. And the guy that started Willow Garage said, "Look, you need to learn how to program or get a new job." And so, in about the course of a year, I became a professional programmer. And so, I think that you guys are getting ahead of the game because that's the direction everything's going. But you know, I will encourage all of you to think about becoming classically trained in an engineering, a more classical engineering field, like electrical engineering or mechanical engineering, because it pairs well with your program. So I would suggest doing a minor in CS while you're at school, and maybe your master's in CS, but getting a more traditional engineering degree along the way. It'll make you a lot more versatile. It'll make you a lot more able to go work at a robotics company if that's something that interests you. Because the thing that's happening more and more is we as a country and as a field are looking for more systems engineers. And that means that people need to have multidisciplinary skill sets where they have backgrounds in other things outside of just programming, be able to turn a wrench, as it were. Um, and so I worked at Willow Garage for the entire time it was in existence. So I was a second employee, and I was there basically until it shut down. And Willow Garage was a very interesting place. We worked on a lot of open source software. We developed ROS, which is kind of like the Linux of robotics. I was a core developer for ROS for about 5 or 6 years. Um, and then, something happened at Willow Garage that caused a shift. The founder came in and he said, "Congratulations, you guys have made open source happen. Now, figure out what's next." And for 2 years, we spent a lot of time building prototypes for uh, potentially different things that could be done with robots. We spent a year looking at, should we build robots for the home? And the answer is no. Really, if anyone tries to trick you into joining a robotics company for the home, run away. Um, there's a big challenge over the next couple of decades in building robots for the home. It's the price to expectations barrier. So people kind of assign value to things based on how useful they are in their daily lives. For example, a car has a lot of value. It gets you from point A to point B. A dishwasher has a lot of value. It cleans your dishes. The problem is that all of those devices have an intrinsic amount of value based on their price. You wouldn't pay $30,000 for a dishwasher. You'd probably wash your own dishes. But you would definitely pay $30,000 or $10,000 for a car because it can get you someplace. But the problem is today for a robot to lift a gallon of milk costs about $30,000. And so everything that people get excited about in robotics, we can't build for their price expectations. And so at Willow Garage, we looked at the home and we decided we shouldn't build robots for it. And then we spent a year looking at different areas. We looked at hotels, elder care, hospitals, retail, grocery, manufacturing, logistics, and we built prototype robots for that as well. And it was a pretty exciting time. However, the founder came in one day at Willow Garage and said, "You know what? You guys should all go start your own companies. I'm shutting this place down." Um, and he just walked in one day and shut the whole place down. 170 people gone. Just go find new jobs. And around that time, before he came and made that announcement, I had decided that me and the team that I was working with had all decided that we were going to go start a company. And so we ended up going and starting a company. And this is something, if you're ever thinking about being an entrepreneur, I have some advice for you with regards to that. Entrepreneurship is very hard. And I know lots of people say that, but it's hard for a lot of different reasons. But one of the things about entrepreneurship is that um, there's a lot of things you don't know, and those small things that you don't know can really hurt you in the long run. And so on my first company that I started a company called Unbounded Robotics. I spun it off of Willow Garage, and we got kind of a bad lawyer because we were trying to save money. Not, I mean, they didn't seem bad to begin with, it was just a lower cost lawyer. And we had a spin-off agreement, and that spin-off agreement had problems with it. And about 11 months into starting the company, we had an acquisition offer from Amazon. And unfortunately, our acquisition offer had problems in it, and we couldn't get acquired because we got a cheaper lawyer. And so I will say, if you ever want to start a company, don't get a cheap lawyer. Um, but because if you fail an acquisition, it's really hard to continue that company because the long-term value of the company isn't there. No one wants to invest in it. We ended up shutting it down. And then I convinced those same co-founders to start Fetch Robotics. And so we started Fetch Robotics about 7 years ago. Um, we build autonomous mobile robots for the logistics industry. Our robots transport packages in warehouses and in manufacturing facilities. And in August of last year, we sold the company to Zebra Technologies for $305 million. So we had a good exit. But that's kind of me in a nutshell. But I'd really like to hear from you guys what you're interested in, what kind of questions you have, and see if I can help answer them or give you some perspective. Anyone? Come on, guys. You guys got to have questions. I believe in you. No one? All right. Well, um, I'm not really sure where to go from here.
Give it a second. I'm pretty sure they're thinking.
Okay. Mm. Yeah, what are the most useful languages in programming? Or what are the most useful programming languages in robotics? So the two most common that people do in robotics today are predominantly C++ and Python. That's including things like lower level languages for firmware. Um, like C would be typically something that you use in embedded programming, for example. Um, but in general, the two largest supported client libraries in ROS today, for example, are Python and C++. And I know that that's a big divergence probably from what you guys learned today. You guys are probably learning JVM type languages and things like that. But um, I would strongly encourage you to learn C or C++, most likely C++, largely because when you run things on the robot, you really care about computational time and process consumption, CPU consumption, and memory consumption. And a lot of the systems are hardware limited, so you need to write efficient code. And the challenge with Python is Python has some limitations. Python's great for prototyping, for building one-off things. Sometimes it's used in production. But for example, at Fetch, everything that runs on our robots today is exclusively done in C++. All right, next question. If I could do it all over again, what would I do differently, mostly in terms of education? Um, I probably would have double majored in computer engineering instead of physics engineering. Um, or I would have done a minor in CS. I still would have done mechanical engineering. The the only other thing is I probably would have spent more time learning a second language. It's actually really useful. And not knowing a second language is somewhat limiting at times, especially if you're thinking about learning a second language. German is a good one to learn as an engineer or roboticist. Sorry, Nicole. I know you know, you're close to Spanish. Or Japanese. Um, those are definitely languages to consider. I wish I had learned a second language more strongly. I learned Spanish, but I speak Spanish very poorly, slash not at all. Um, but yeah, I would say that I wish I had potentially done more electrical engineering or computer engineering. But I think that's, you know, that's a hard thing to look back on and decide educationally what I should have done more of. I will say that, I got a lot out of going to a big school like University of Illinois. I did a lot of different, I guess, extracurriculars. One of them was actually a program called the Floating Illini. So whatever school you guys go to, if you have the ability to participate, there's a program that's run by NASA called the Reduced Gravity Student Flight Opportunity Program. A lot of universities have these programs, or teams that participate in the program. It's an opportunity to go fly on the KC-135, or I guess now it's a DC-9, to do microgravity experiments. I highly recommend it. Let me see if I can show you guys a picture really quick of what that looks like. You basically get to go have fun in microgravity and do experiments. It's a lot of fun. So I highly recommend it. There's nothing like being weightless. But yeah, I don't know. I think that those are the types of things that I would say is get involved in extracurriculars, do a lot of internships, find out what you like and don't like. Um, I think one of the challenges um, is finding out what kind of work you want to do. Like I did a whole bunch of internships and I found out that I didn't want to wear someone else's polo and khakis. I really just disliked it. And so yeah, but yeah, here let me show you guys this picture like really quick. Hopefully it'll load. Nope. Uh, Hold on.
And Melanie, while you're working on that, I'm looking at the chat for the questions. I'm going to jump around. This one might be a short answer. What's the difference between mechanical engineering and electrical? That one's kind of related to education.
Yeah.
So we'll jump to that.
Yeah. So mechanical engineering typically focuses on the fundamentals of mechanics, which is like stress and strain, properties of materials, thermodynamics. Um, it's if you look at it, mechanical engineering in some ways is separated into other specialized fields. Like in mechanical engineering, you look at fluid flow through a pipe. In aerospace, you look at fluid flow over a wing. In civil engineering, you look at fluid flow through an aqueduct. Um, but we're all kind of doing similar engineering. Whereas in electrical engineering, you're typically focused on the field of electronics, circuit board analysis, circuit analysis, and there's some nuance because some schools offer computer engineering programs and separate electrical engineering programs. And so typically computer engineering programs focus on things that are specific fundamentally also to computers, like you learn about compilers, you learn about how um, the fundamental code works, like how you decompile code, how that works in terms of how you build a computer, how does a computer fundamentally work, bits and bytes and things like that. Whereas electrical engineers are fundamentally concerned with like things like current through a circuit or diodes or how an LED works, or how RF transmission works, how RFID works, how some of these fundamental things in electronics work. And so depending on what you're interested in, mechanical engineering has these branching fields, where you fundamentally learn all the same things, but they have different concentrations. Like civil engineering is buildings, mechanical engineering is pipes and machinery, and aerospace is more like the application of those things in flight. But like I was saying, one thing that you can do is you can get involved in programs that give you the opportunity to do something like this, which is experience microgravity. So this is me with an experiment, and there's no gravity. So it's not like I'm super strong. Like the plane is falling through the sky. But I encourage you to get involved in programs like that to apply what you're doing. Let's see, what's my favorite part about robotics? It depends. I'm more of a systems person, so some of my favorite part about robotics is bringing it all together, building all the code that brings all the component parts together. Because great, you can make a robot navigate, but if you want to like navigate to a table, pick up a bowl, bring that bowl to a table, those are component tasks are being assembled into a much larger thing that actually does something meaningful that you care about. And that's definitely something that I enjoy a lot. How do I motivate myself when I encounter obstacles? I don't know. That's a difficult question, because I think the first thing that you have to ask yourself when it comes to talking about difficult times of your life or in obstacles, it comes back to how you view goals, goal setting, and what satisfies you. One of the things that I would encourage all of you to understand about yourselves is what kind of goal setter you are, because it helps you to understand other people pretty well. Because people fall into a couple types of groups for goal setting. There's people who like to set goals that they will always achieve. In fact, it's very easy for them to achieve, but they like to achieve lots of goals. So they'll make a list, and every list is a very small goal that is definitely achievable. Then there's people who like to set goals that they want to tackle one goal at a time, but that goal is achievable. And that is important to understand, because if you look at just those two types of people who like to achieve lots of small little goals and people who like to achieve one big goal, the way they work together can be sometimes conflicting. But some people find motivation in those types of goal setting. Then there are people who like to set goals that are just out of reach. They have to stand on their tippy toes. And they may not achieve the goal, but they gain a lot of satisfaction from working hard to stretch to reach that goal. But sometimes that kind of goal setting can be very demotivating for the other two types of people. And so when you work with other people, you have to be aware of what kind of person they are and how they are motivated through goal setting. And then there's people like me, who like to set goals that can never be attained, or they are almost impossible to attain. And it's something that I learned as a CEO that is a very difficult type of personality to have, because it's very rare for people to be like me in terms of their goal setting. But when we try to set goals like we do for ourselves with our coworkers or our employees, it can be very stressful and demotivating. And I gain a lot of motivation out of striving for something that is impossible. But not many people gain that kind of motivation. And I will say that one of the things that, for me, a lot of my challenges are not specifically in technical obstacles. Like, I believe that most things can be solved technically. I think the bigger challenge that you guys will find in life is not really technical obstacles that become very difficult. They're interpersonal obstacles, they're people obstacles, they're emotional obstacles. And those are the things that are very hard, is picking yourself up after a big emotional setback. For example, say your first company tanking. Um, and I will tell you that you're going to have these periods in your life, and one of the things that I would say that is nice is that it's gotten easier to talk about those things openly, and people understand what's going on. You know, when my first company failed, it was really hard for me. I spent probably a good month in bed, um, and and I think that, you know, a lot of it comes down to, you know, being able to have people around you that you can talk to, and also believing that you can continue forward. I think a lot of people let their challenges eat them up and make them believe that they can't do something. And I think some of that comes back to goal setting. And sometimes it's very easy for me to dig out of these holes because I fundamentally don't believe anything is impossible in some ways, because I always set goals that are impossible. Um, let's see, what else? What would you say is the most important part about building a robot? Sensors. When building a robot, the most important thing is to know about the sensors, how they're going to be used, what type they are, and will they solve the problem you care about, and making sure that you build the robot around the sensors. Everyone believes that the motors and everything else matters. Actually, you fundamentally can't have an operational robot unless the sensors do what you're trying to achieve. And so a lot of people start by building the mechanism and then adding the sensors, but you really need to build the robot the other way. You build you design where the sensors are going to be, and then you build the robot around it.
All right. Thank you
Any
so
other
much.
questions?
Yeah, thank you so much, Melanie, for your time here today. I think
Yep.
it's almost 1:50 and everyone has
Okay.
to get back to their classes, but we really
No
enjoyed
worries.
hearing from you.
Yep. Awesome. Well, thank you very much. Please feel free to reach out to me if you have any other questions.